Today we are going to talk about composite construction of prestressed and in-situ concrete. So in a composite construction, the precast prestressed members are used in conjunction with the concrete, which will be cast and cast in situ. So the members as a whole will behave as a single unit while it will be in service. And high strength in the generally the high strength prestressed units are used in the tension zone, while the concrete which is cast in situ of generally relatively lower compressive strength is used in the compression zone. So high strength prestressed units are generally used in the tension zone, and the in situ concrete will be used in the compression zone. Now the composite, while using the two different concrete, so one is prestressed concrete, another is the will be cast in situ concrete. So how we are going to get a composite action out of it? So it can be achieved in different ways. So one is that you rough generally you roughen the surface of the prestressed unit, and then you cast the concrete, and thus giving a better friction resistance. Or it can be happen while you are making the prestressed unit, you keep the stirrups outside of it in in a protruding manner, and then you add the concrete. Or some other way also it can be done. So the main advantage of using it, there are some, is while you are using the precast prestressed unit and in this composite as a composite construction, so you can reduce the precast prestressed units, so the dead weight will be much less. Also, if you are going to use the whole section as reinforced or prestressed concrete member, so your requirement of steel will be much more. So if you go for the composite construction, the amount of steel will be less, so the also you are saving the cost. And in many cases the precast prestressed units you serve as a support, because in the support section the tension will be much more. So if you in this tension for the tension you are using prestressed members, so precast prestressed units can use as support, and so you can dispense with the form work generally while you are using the in situ concrete. So composite members are generally, and this extends to that composite members are ideally generally suited for constructing bridge decks. So you don't have to disrupt the normal traffic. You are using prestressed precast members in the factory, and then you are from there to you're coming to construction side with that, and then you are using the cast in situ. So you are not the main biggest portion of the construction you are doing in the outside of the site. So without disrupting normal traffic much, you can go for construction bridge decks, especially in the big cities or high traffic areas. So you are using effectively what is the strength of precast members is tension tensile strength, and in general the concrete has is strength in the compression zone. So you are using both. So you are using cast in situ for the compression zone, and when the precast members in precast prestressed members in the tension zone. So you are effectively using the both material in the composite construction. Also, combination of lightweight concrete for the cast in situ slab result in reduced dead load, so leading to economy in the overall cost. So you are reducing the dead load and weight. You are reducing the size of precast members. Also, you are using generally lightweight concrete because you are using it for compression zone only. So as a whole, the dead load is getting reduced. So that's a good thing while you are going for a economical viable construction. The most common type of composite construction consists of a number of precast pieces, inverted T-beams, and which will be placed by side, and then it will be connected by a continuous top slab, which will be cast at the site itself. And especially this type of construction widely used in construction of bridge decks. And there are some like transverse pre-stressing also can be used to develop monolithic action in the lateral direction. Also for large span composite bridge decks, which let's say exceeding 30 meters and more than that, that commonly used precast members are consist of box sections. And that case also box section or I section which will be placed side by side and then it will be interconnected through a cast in situ deck slab. Now the dead load stress also can be much more minimized if you use props while you are casting the concrete in situ. This method of construction is known as prop construction. And if the precast units are not propped while placing in situ concrete, so then stresses will be developed in the unit due to self weight of the member and dead weight of the in situ concrete. And this method of construction is referred to as unpropped construction. So if you want to analyze the stresses in the pre-stress and cast in situ concrete, so you have to generally go for simple bending equation, which is nothing but the normal stress due to direct loads, and another part is due to bending moments. So as a whole, what will be the normal stress in the whole composite section? Now, if the precast pre-stress unit is not propped during the placing of in situ concrete, the stresses that will develop in the precast unit is generally from self weight of the member, from the pre-stressing force acting at a given eccentricity, and also due to the self weight of the in situ cast concrete. And after the in situ concrete has hardened, then the whole section is assumed to be monolithic, and the stresses that develop due to uh, subsequent live loads are computed using the properties of the whole composite section. But before that, before the in situ concrete has not hardened, then then you have to go for the stresses develop only in the precast unit. But after the in situ concrete has hardened, then the stresses that develop due to live loads, subsequent live loads, that will be computed based on the whole composite section, not only precast but precast plus the cast in situ section. Whole section you have to go for if the precast pistis unit is not propped. So you have to remember that the precast pistis unit, if is not propped, then the stresses which will be developed in the precast unit will be because of self weight of the member, because of the prestressing force which is acting at some given eccentricity, and self weight of the in situ cast. All these stress, all because of this, the stresses will be developed in the only in the precast unit, not in the whole unit. After in situ concrete has hardened, then you have to go when whole section you have to consider while you are calculating the stresses. However, if the precast unit is propped while you are placing the in situ concrete, then the stresses developed due to the self weight of the in situ concrete are computed using the composite section. So that is the basic difference. While if it is unpropped, the stresses developed in the precast unit due to the self weight of the in situ cast concrete, and that you have to go for the section only for the precast unit. But while you are using propped during during the placement of in situ concrete, then the stresses develop in the due to self weight of in situ concrete. There you have, that stress will develop in the whole section, not only precast unit but on the whole section. So that is the basic difference. But for both cases, then the live load stresses will be computed based on the whole section, not only precast unit but also the in situ unit as well. So as a whole section you have to compute this. So the stress distribution while looking, so the basic difference will happen while you are calculating the stress developed due to the in situ concrete. Okay, so the self weight of the in situ concrete you have to consider for both cases. But in the unpropped construction, the, the stress developed due to self weight of in situ concrete will be only on the precast unit, while uh, the self weight of the in situ concrete, this because of the stress because of this particular part will develop in the whole section, the prop construction. So remember, this is the basic difference. So if you go to the note and you do the math, the example problem there, so you will get the idea what I'm saying here. And also if you see the typical stress distribution, you will get the idea what I'm saying. The main difference is coming the stresses due to the cast in situ slab. For unpropped, it will be only in the precast unit, and in the prop section it will be in the whole section. So that is the basic difference. So remember it and just look for it while you are calculating the stresses. Okay, thank you.